So let me welcome Oli Bage to the stage to talk about CDMC and AI. There you go.
Thanks, John. Can everyone hear me okay? Yep. Good nods. Okay, hello, I'm Oli Bage. I am Head of Architecture for the Data Analytics Division at LSEG. It's one of the world's largest data companies. You may have known us as Refinitiv or Thomson Reuters or Reuters Market Data, which everybody actually has heard of. That's my day job, but I have a fairly sizable side of desk job partnering with our customers and the rest of the industry to lead some working groups at the EDM Council and some other areas as well. I want to talk about the progress we've been making to extend the CDMC framework for AI over the last couple of years and just give you a taste of that, and then give you a taste of it in action as well, where we'll trace the data lineage of all the data in a frontier foundation model in 5 minutes flat, hopefully, if the countdown will let me go. So about 5 years ago, I was working in the Centre of Excellence for Data at Morgan Stanley, and we had to move a load of applications to the cloud. We wanted to put pressure on the cloud companies to try and implement some of the automated data management controls that companies like Morgan Stanley had at the time. So we created, with the help of the EDM Council, a working group of 17 systemically important banks that was expanded out to around 150 organizations, around 300 SMEs. And we spent 45,000 hours writing the CDMC framework, the Cloud Data Management Capabilities Framework, which we published in 2021. And over the course of the last, I guess, 3 years, more and more of the cloud companies and other technology providers have been either certified or have fully implemented CDMC. The next phase up the stack, though, and there was demand to do this in the original CDMC that we didn't really have time to do in the first go round, was to apply those same data governance principles to analytics, financial analytics to start with, and then AI got very, very popular partway through the working group. So we created a working group led by LSEG and Databricks with important contributions from Standard Chartered, UBS, JP Morgan, Standard Bank, and 30 other groups. In fact, there are 95 people who on and off join the working group from time to time. We meet on a Monday at 3 o'clock if you fancy coming and joining us. We've extended the CDMC framework to cover AI models and other financial models, so the deterministic side of analytics and the probabilistic side. We've included the key principles behind the NIST AI risk management framework, which lots of tier 1 financial institutions are basing their AI risk management on. We've included concepts in data ethics and some important classifications from the EU AI Act and some open source terminology from the ML Flow framework. And we published a draft of the ADAC framework in December last year. So there's a very short, easy to read, 3-page document with a nice infographic to open. In fact, it's this infographic to open, which shows you what we've come up with. Broadly speaking, if you're familiar with CDMC, there were 14 key controls in CDMC. There are 15 in the ADAC framework. 10 of them are broadly just a minor extension, where previously we said data asset, now we say model, AI, project, environment, whatever you're governing as your asset definition has been broadened. But 5 of the capabilities needed to be heavily extended, and that's the ones you see across the top. To go into a little bit more detail, the 5 that we spent a lot of time on were how you extend use case governance to be an ongoing AI use case governance framework where human beings get to determine the parameters of when they want to see the AI projects come back to them. Typically, they want to know, is there any ethical impact to this project? Is there a privacy impact to this project? How do you measure the model quality of your AI assets, and how you provide these kind of performance windows which describe when you need to come back and measure things like bias and drift. There's a very mature area of quality control for model risk management that we work closely with from a number of large banks, and also LSEG's model control team. We run a big set of quantitative analytics for the industry, so products like Yield Book that you might have heard of for fixed income. So our head of model control was given the additional responsibilities to run AI risk, and Sonia Hukovic and I together put this framework together. The framework is actually quite useful for bringing together your model control and AI risk team and your data governance team. So if you've got those two teams either collaborating on AI risk or are working side by side, this can be a kind of Rosetta Stone for both sides to be able to refer to each other and see where you fully overlap. So things like having a catalog of all the assets, whether they are models or data sets or trained models or analytical outputs like reports that have come from those trained models, knowing how they classify, what's sensitive, understanding how you've applied the right level of security and retention and archiving and ownership and authoritative data sourcing and data quality measurement to them, and also cost and sustainability metrics. There's a very high correlation between what your model is costing to run and its environmental impact. Probably the most fun area of new capability, though, is the audit trail space. It's like, wow, fun audit trail. Nobody's ever said that before. But we thought, why talk about the ADAC framework in the kind of abstract? Why not show an example of it in action? So we weren't able to use one of the AI projects for many of the members, but we picked an open model from Hugging Face, which is one of the frontier models with performance similar to ChatGPT, but all of its training data is out in the public domain. So although you can go and download the ADAC overview document and it has this kind of scoreable framework in it, let's apply the lineage and audit trail to a model called Olmo 232B. So this is from the Paul Allen AI Institute. Olmo is the open language model, and 32B is their biggest model. It's got 3 phases to its data consumption: a pre-training, mid-training, and post-training. We dived into the pre-training and went for the top 20 sources in there. It's made up of a thing called the DCLM baseline, which is a copy of the internet. A copy of the internet. I'll drill into that in a second. It's also got a copy of a thing called Archive, which is lots of research papers, and PES2O, which is another copy of lots of research papers from the academic space. It's got a copy of something called StarCoder, which a project called Big Code have created from a thing called the Stack. It's a copy of all of the freely available code on GitHub. So it's small and medium-sized projects, nothing big or enterprise-wide there. And then there are 2 maths data sets in there. Algebraic Stack, which has got a copy of the code for a proof system in it. So in theory, your LLM can do a bit of maths. And then Open Web Math, which is a copy of all the textual maths on the internet. And then there's a copy of Wikipedia, but that's not the only time that Wikipedia shows up. So let's dive into the DCLM baseline. This is the data comp for language models. It's a research project that it focuses on the data for large language model training. The DCLM baseline is 7 terabytes. It's created from a fast classifier that Facebook have open sourced that knows what high quality web pages look like. And so you run through and it gives you the top 10% of the web pages that it's given. So the DCLM baseline is based on a 46 terabyte extract of DCLM refined web, which is based on a 300 terabyte extract with that same quality filtering out of DCLM pool, which is based on the 9.5 petabyte copy of the Common Crawl. And that is actually a copy of the internet, but it's only 9.5 petabytes. And you'll all know that the internet is bigger than 9.5 petabytes. This is, the Common Crawl is hosted on AWS. It is the freely available domains on the internet, and it's made up of 44% English language web pages, dominated by Blogspot, which is an end-user content hosting site from Google. 18 million pages of Blogspot in there. Wikipedia's in there with 5 million pages. Pinterest, the number 3 site feeding your large language model, so it's great at mood boards. With 3 million pages, and then you're into the 1 to 2 million pages. The first time any high-quality content turns up is the Online Computer Library Catalogue, OCLC, which is about halfway down there. And then Oxford University, other universities are available, of course, and then ISO Standards Organization. So not masses of high-quality content in there yet. The second biggest language in this training set is Russian, 6%. Then German, about 5%, but you can see it's coming from europa.eu. This is the homepage of the European Union. They simultaneously publish all their documents in 27 languages. It's very, very high quality translation. It takes them a full year to translate all of the languages and get everybody to sign off and say, yes, these are perfectly represented in all the languages. So it's a great translation read-across site. Then you've got 5% Japanese, which is mainly user-generated content again. Then you've got 5% Chinese, but it's not mainland China, it's Taiwan. So Pixnet there, you see, is the Taiwanese user-generated content hosting site, the main site that they've got. And then you can see on this picture, nicely provided by Solidatus. Thanks, Phil, for the free license there. EDM Council, by the way, if you log into EDM Connect, you can open this model and play around with it. It's just there in the Sol Datas instance that's got all the other EDM Council material in it. And you can see here the Europa.eu site feeding lots of the other languages that are in the top there. So what can we conclude? Lots of self-hosted sites, lots of academic and government material, not a lot of professional content, sort of none that we could see there really. And a little advert, LSEG's a data company. We sell about 12 petabytes of data that isn't just the history of all ticks that's ever happened on every exchanges ever, which is about 100 petabytes. But that compares very favorably with the 9.5 petabytes that you're training your large language models on. So you can conclude this model is going to be good at academic language, great at encyclopedic knowledge. It'll be fantastic at generating end-user grade content, but it'll be weak on professional language, weak on proprietary knowledge. So there you go. My time is up. I don't even know what the next slide is.
I don't even know what to say after that.
Right.
That was just fantastic. But I think hopefully it addresses the questions about how do we take these frameworks and apply it to real world examples. And this work group, Oli was the pioneer in helping us drive CDMC and continues to be a fantastic partner, and LSEG as well. So I thank you for that. And learn more. You're not going anywhere today, are you?
No, I'm here all day.
So grab a hold of Oli and learn more about that. Oli, thank you very much.
Thanks, John.
There you go.